everyone, Mrs. Greenman here. I'm going to talk to you today about logarithms. Before we start with the new material, let's review what you learned in the previous lesson. So in the first problem, we're asked to solve for x. So we have 3 to the power of x plus 1 equals 81. So remember, when you are solving these exponential equations, you want to equate the bases or make the bases the same, because when the bases are the same, you can set the exponents equal. So we have here 3 to the power of x plus 1 equals, and now we need to think about 81, if there's a way to rewrite 81 with a base of 3, and 3 to the 4th power is 81, so because the bases are now both 3 on the left and right side of this equal sign, we can equate, set the exponents equal to each other, and we can solve, and we get x is equal to 3. If we take a look at the next one, we have 4 to the power of 2x plus 1 equals 8. So again, we want to try to equate the bases, make the bases the same. So in this example, we're going to actually have to work with both sides of the equation. So we need to think of a way to rewrite 4 and 8 so they have the same base. Now we know that 4 is the same as 2 squared. So I'm going to write 2 squared because that's the same as 4. And I'm going to put that in parentheses because that 4 was being raised to the power of 2x plus 1. And 2 squared is the same as 4, and 8 is the same as saying 2 cubed. Okay, so now that the bases are the same, we can set the exponents equal and solve for x. Now remember, when you have a power, so this squared being raised to another power, remember we're going to just multiply. So we have here 2 times 2x and 2 times 1, so we're multiplying here. So we have 4x plus 2 equals 3. And now we can just solve for x, and we get 4x equals 1, x equals 1/4. Okay, in this next example here, we want to try to do the same thing. So if I want to think about 4, how could I rewrite 4 so that it has the same base as also rewriting 9? And in this case, it's not possible, so we can't do this just yet. And you'll learn later on in this unit how to work with something like this when you can't rewrite and equate the bases. Okay, so what I want you to do in your calculator, you're going to find the log here. So if you have a graphing calculator, if you look at the on button, if you go 3 keys above, you'll see the log key. So you're going to put log and then 0.1, log of 0.01. So take a moment to do that on your calculator and let's see what you get. So if you put this in your calculator, you should get the log of 0.1 is -1, log of 0.01 is -2, log of 0.001 is -3, log of 1 is 0, log of 10 is 1, log of 100 is 2, and log of 1,000 is 3. So I know you don't know what a logarithm is right now. We're going to talk about that. So what do you think on our calculator this log function gives us? So let's think about it. We did the log of 1,000, we got 3. The log of 100, we got 2. The log of 10, we got 1. The log of 1, we got 0. So what is this really doing? Well, this is really just giving us powers of 10. So if you think about how we could rewrite this as a power, so 10 to the 3rd power is 1,000. 10 to the 2nd power is 100. 10 to the 1st power is 10. 10 to the 0 power is 1. 10 to the -3rd is 0.001. 10 to the -2nd is 0.01, and 10 to the -1 is 0.1. Okay, so when we're talking about logarithms, a logarithm has a base of 10, and that's called the common log, and it has many applications in science and engineering, and we're going to look at logarithms today where the base is not always just going to be 10, so we're not always going to have just a power of 10 here. Okay, and what we're going to learn today first is we're going to talk about what a logarithm is, what the notation is, and we're going to work on how to rewrite from log form to exponential form and vice versa, and how to solve some equations. So let's take a look down below. Okay, the logarithm of a number is the exponent to which a base is raised in order to get that number. So we're going to talk about the notation here, and then we're going to look at some examples with numbers to make a little bit more sense. Okay, so we have the logarithm. Okay, so let's color code this so you can kind of see in exponential form and log form where things go. So we have the logarithm of a number is the exponent to which a base is raised in order to get that number. So here, y is the exponent. Okay, so we're going to circle that. I'm going to color code that. B is the base. So B is the base. And x is something called the argument. Okay. The logarithm y is the exponent to which the base must be raised to get x. Okay, so if you take a look at this chart below, we have here that we have the base being raised to an exponent is equal to the argument. Okay, base being raised to an exponent is equal to the argument. And if you look at that in log form, you have the log of the base. Here, whatever your base is, you have argument equals your exponent. So you can see that we're using the same three terms, base, argument, exponent, and where they're located here. Okay, there are some restrictions here that we have to include. So for the value of x, x has to be greater than 0. Okay, the value of b has to be greater than 0, but the value of b cannot equal 1. So let's take a look at why those restrictions are there. Okay, so let's take a look here at an example. So if we have, let's say, b to the y equals x, okay? So it says here that b has to be greater than 0 and b can't equal 1. So if b were to equal 1, if the base were to equal 1, so just think about how an exponential function works. So if the base is 1, and I also want to mention that your exponent is any real number. So the exponent here, this y, is any real number. So if we take 1 and we raise it to the first power, 1, and we raise it to the second power, 1, whatever power you raise it to, you're going to get 1, and that's not going to be an exponential function, that's going to be a horizontal line, y equals 1, okay? If the base is equal to 0, so if you had like 0 to the first, 0 to the second, etc., you're going to get 0, and that's just the equation y equals 0, or the x-axis. It also has to be greater than 0 because if your base is negative, okay, so let's say you had negative 2 cubed, we could evaluate that and we would get negative 8, but we could also say, well, what is negative 2 to the 1/2, or if we take the square root of negative 2, it's an imaginary number. So these restrictions here apply for our log form and our exponential form. X has to be greater than 0, b has to be greater than 0, and it can't equal 1. Okay. So how do we read this? If you have y equals log with the b and x, it's read as y is the log of x base b, or you could also say y is the log base b of x. So let's take a look at some examples here on the next page. Okay, so here, as I mentioned on the page before, you have that the base is a small number written as a subscript of log. 8 is your answer or your argument equaling your exponent. So you can kind of see where the base goes here, it's color coded, where your answer or your argument goes, and where your exponents go. Okay, so 3 is the exponent to which the base must be raised to create an answer of 8. Okay, so this is both log form. So if you wanted to rewrite it in equivalent exponential form, it says here that the base of 2 must be raised to the exponent of 3 to get your answer or your argument. So 2 cubed gives you 8. So we can use this kind of spiral notation to help convert from exponential to logarithmic form. So the key thing you want to remember is that a logarithm is just an exponent or a power. Okay? So what we're going to do in this chart below is we're going to be given some examples of exponential form, equations in exponential form, and we're going to rewrite them in their equivalent logarithmic form. Okay, so we have 3 is our base, we have our answer or our argument, 243, and we have our exponent. So I like to start with my base, and I like to draw an arrow going like this to help me remember what's going to come first, second, and third. So I'm going to rewrite this. This is equivalent to the log base 3, right? The base was 3 over here, okay, and the base goes over here. So log base 3 of 243 equals 5. Okay, Let's try another one. So again, we're going to start with our base. 8 is our base. We're going to go with this arrow to help us remember. So we start with 8, we go to 1/4, and then we get negative 2/3. So we say the log base 8 of 1/4 equals negative 243. Okay, so the base, okay, we have our base over here. Our base is 8. The base is 8. We have our exponent of negative 2/3. Here's where the exponent goes over here. This is our argument or our answer, and this is our answer or our argument. Okay, let's try another one. We're going to start with our base. Even though it's fractions, it's the same way to do it. Start with our base, go around. So we have log of 27 over 125, 5/3, equals negative 1/3. So we're just saying that in the exponential form column and the logarithmic form column, these two things are equivalent. We're just changing the form that we're writing it in. Okay, now we can go from the column on the right, we can start with something in log form and rewrite it in exponential form. So we start with the base, so here's the base, and we can do that same arrow motion to help us. So 2 is my base, so it's going to be 2 to the 6th power is 64. Okay, do the same thing over here. 2 to the negative 3rd is 1/8. 729 going like this, so start with the base. 729 to the 1/3 power equals 9. Okay, why are we talking about this? Because sometimes you're going to be given an equation in log form, and it's going to be easier for you to rewrite it in exponential form and use some of the information that you learned in the lesson yesterday about how to equate the bases and how to solve. So let's take a look at some practice problems. In these practice problems, we're going to be solving for different parts of our log expression or equation. So in some of them we're going to be looking for the exponent, some of them we're going to be solving for the argument, and some of them we're going to be solving for the base. Okay, so let's take a look at some practice problems. Okay, so it says, what is log base 4 of 64? Okay, so this is not something you're going to just go ahead and put into your calculator. Okay, so in other words, you want to think to yourself, okay, what is this equaling? So I'm going to put equaling x. So basically you want to ask yourself, we're solving for the exponent. So we want to say 4 to what power is going to give me 64, okay? Because remember what I said before is that a logarithm is just an exponent or power. So if I want to find the answer here, I've got to think of 4 to what power is going to give me my 64, okay? So 4 to the 3rd power is 64, so x equals 3. So 3 would be my answer here. Okay, so I can say this here, 5 raised to what power? So I'm just going to set this equal to x. 5 to the x power is 625. So 5 raised to what power is 625? And the answer is 4. 5 to the 4th power is 64. Okay, this one's a little bit trickier. So we have here the log base 2 of 1/8. What does that equal to? So we can just rewrite it as this equals x, and I'm trying to figure out what x is, or my exponent. So 2 to what power is 1/8. Okay, so now we have, instead of a log expression, we have an exponential equation here. And what we're going to do is we're going to try to rewrite this so that both sides of the equation have the same base. So we have a base of 2. So I want to think about how to rewrite 1/8 with a base of 2. 1/8 is the same as 2 to the negative 3rd power. Now that the bases are the same, I can set the exponents equal, and we get x equals negative 3. Okay, so in questions 1, 2, and 3, we were solving for the exponent, okay? We knew the base in our argument. We wanted to figure out what would our base need to be raised to get that answer or that argument, okay? So let's keep going with number 4 and 5. So in number 4, we are solving for the argument. We have the base and the exponent. So if it helps you, start with that base. And what we're going to do is we're going to take this log equation and rewrite it as an exponential equation. So 3 to the 4th power equals x. So now we just need to do 3 times 3 times 3 times 3 to figure out that x is equal to 81. Okay, so 3 to the 4th power is 81. In the next 3 problems, we're going to be solving for the base. Okay, so we're trying to figure out here the log of what base raised to 3 is going to give me 64. So x raised to the power of 3 is going to give me 64. So I'm going to rewrite this in exponential form. X to the 3rd power is 64. So something raised to the third power is 64. You might be able to figure this out in your head, but again, if you can't, remember that when you have something that's cubed, you use the inverse, which is the cube root. So if we take the cube root of both sides, cube and cube root are inverses, so they end up canceling, so we end up getting x equals 4. All right, let's take a look at number 6. Okay, so in number 6, we have an equation that's in logarithmic form. So what we're going to do is we're going to rewrite this in exponential form. So I'm going to start with my base of x, and I'm going to rewrite this. So I have x to the negative third power equals 1/8. So to get x by itself, I'm going to raise both the left and the right side of my equation to the power of negative 1/3. So if I raise this to the negative 1/3 power, what this is going to do for me is I'm going to be left with just x on the left side, because negative 3 times negative 1/3 is just 1. So I get x to the power of 1 equals. Now remember, when you have a base, and in this case on the right side of our equation, the base is 1/8, and that's being raised to a negative power. So remember, when something is raised to a negative power, you're going to find the reciprocal of the base and the exponent becomes positive. So this is going to become the reciprocal of 1/8 is 8. And then the exponent becomes positive, so it's to the 1/3 power. And 8 to the 1/3 power, also the cube root of 8 is just x equals 2. Let's take a look at number 7. So I'm going to start with my base of x, which is what I'm looking for, and I'm going to say x raised to the power of negative 3/2 equals 216 over 125. So I can't do this in my head. I don't know. Some number raised to the power of negative 3/2 gives me 216 over 125. What I'm going to try to do is I'm going to try to solve for x, okay? It's being raised to the power of negative 3/2. I want it to just be x alone, so I'm going to raise each side to the power of negative 2/3, okay? And what that does for me, it allows me on the left side to be left with just x equals, and again, when you are working with a negative power, so the negative 2/3, you're going to find the reciprocal of the base. So here our base is 216 over 125. So the reciprocal there, I'm going to have 125 over 216. Okay, and then the exponent becomes positive, so I have 2/3. But I can continue simplifying further. This is equivalent to saying the cube root, okay, of 125 over 216, and this should be coming back to you from your last unit, and then we will square that result. So the cube root of 125 is just 5, and the cube root of 216 is 6, and then we have to square that result, so we get 25 over 36 as our final answer. So you can check on your calculator anything that we've done. You can say, okay, 25 over 36 raised to the power of negative 3/2 will give you 216 over 25, right? So it's just solving an equation. So if you want to check, and it would be helpful, take your x value and go back to the original and say, okay, plug it in for x, raise it to this power, see if you get your answer. You can do the same thing here. So 2, plug in 2 here, 2 to the negative 3rd power, we should get 1/8. 1/8. Okay, so lastly, we're going to do just a quick recap. Remember that when you have the cube root of a value, so here we have the cube root of 10, that's the same as saying 10 to the 1/3 power. And if you have just 5 under the radical, remember that's the square root of 5, and that is equivalent to saying 5 to the power of 1/2. So let's look at the last two examples here on the bottom, number 8 and number 9. Okay, our goal is to solve for x. Okay, so we have log of base radical 6 of 36 equals x. So I'm going to take this logarithmic equation and rewrite in exponential form. So I have the square root of 6 to the power of x equals 36. So my goal is to find my exponent here. So I'm going to rewrite radical 6 as 6 to the 1/2 power, because it's equivalent, and then we have that x equals 36. Now again, I have 6 on one side, so I want to think about the right side of my equation and see if I can rewrite 36 with a base of 6, which we absolutely can. So 6 to the 1/2 power times x equals 6 squared, because 6 squared is equivalent to saying 36. Now that the bases are equal, they're the same, we can set the exponents equal, and we can just solve for x. And when we solve for x, dividing both sides by 1/2, you get x equals 4. Okay, so again, you can go back and check. You can take the square root of 6, raise it to the power of 4, and you will get 36. Lastly, number 9. we have 7 to the power of x, okay, equals the cube root of 49. Okay, so we can rewrite this as 49 to the 1/3 power, okay? And again, now we want to try to solve this exponential equation by equating the bases. So 49 is the same as 7 squared, and 7 squared is being raised to the power of 1/3. Now remember, when you have a power to a power, you multiply those exponents, so you have 7 to the 2/3 power. Now that the bases are equal, they're the same, we can set the exponents equal, and we get x equals 2/3. Hope you enjoyed that lesson. Now you're going to work on your homework so you can get some extra practice with logarithms and exponential equations.